Everybody, thank you for spending part of your day with us. Again, our presentation is on Exposure Data Audit, which we're uncovering PII information in your SQL Server environment. As Erica mentioned, my name's Alan, and I'm Principal Consultant with Pragmatic Works. I've been with Pragmatic Works roughly 4 years now. I do have a blog at falcontechsolutioncentral.com. And this essentially is, you may, as a BI architect, developer, or whatever your role may be within your organization or possibly within your project, for example, you may need to conduct a exposure data audit to uncover personally identifiable information or PII related data within your SQL Server environment. In this case, we're going to be looking at PII within a SQL Server 2016 environment. The objective is to uncover any potential data security exposure risk in a continued effort to consider and implement enterprise-grade security policies. Microsoft SQL Server 2016 introduces new features, improved performance, and continued effort on providing options to implement enterprise-grade security. At the tail end of our presentation today, we'll talk about those at a very high-level overview perspective. Really, the purpose of this presentation and demos is to outline a solution using SSIS, T-SQL, and PowerBI to locate and analyze the PII information stored in this case, our SQL Server 2016 environment. The U.S. Department of Commerce defines personally identifiable information as any information about an individual that can be used to distinguish or trace an individual's identity, such as a name, social security number, a date and place of birth, mother's maiden name, or biometric records, and any other information that is linked or linkable to an individual, such as medical, educational, financial, and employment information. You know, it's very common that we start seeing these headlines where annually data leaks expose information on millions of people, potentially raising the risk of identity theft for those whose information is exposed. For example, just recently, I received an email from one of my service providers around my personal applications that I use, and it said that the database security growing demand for sophisticated security solutions involving regulatory landscapes are the key drivers for this industry. So what they're saying here is that the database security market is expected to grow from about 2.95 billion in 2017 to over 7 billion by 22, and which is about an 18 to 19% growth during that period. So the growing demand for sophisticated security solutions involving regulatory landscapes are really the key drivers to this type of market and this type of solution. So using a combination of T-SQL, SSIS, and PowerBI to locate the PII information stored in this environment. Initially, I was working in a situation where we had a dev, QA, and production environment. Our QA and production environments were had security like transparent data encryption, those types of things apply. But in our dev environment, we didn't, because it was a least restrictive scenario. So we did an exposure data audit on those. And we basically use T-SQL and SSIS to crawl or inspect the information schema to retrieve metadata about the objects within each database located in an environment, specifically tables and views and columns. Then Power BI is used to visualize and inspect the data. We also introduced the notion of a risk rating scale. And essentially, risk is the probability that a hazard will result in adverse or result in adverse consequences. Assessing the risk of the potential hazards helps to determine the proper mitigation strategy and priorities. In our discussion, we'll focus on rating risk, usually using probability of occurrence and severity of consequences or scales. So with the exposure data application, we're going to be looking at, in an automated way, assist with identifying the risk based on column naming standards and the potential values that they may hold. So the assessment criteria was initially described as columns, anything that might have the potential to be PII. The exposure data audit solution based on the assessment scale used in a basic way provides what risk interactions may occur. Based on the latest exposure data audit run, you can review the data using the visualizations and sample data values captured and potentially prioritize the risk or possibly adjust the logic to refine the categorization of such risks, therefore interactively permitting how to respond to the risk. So what we will talk about and review today is within Visual Studio, I have a database project. I also have an SSIS project, a fairly straightforward SSIS project, which we use a series of T-SQL and some of those transformations to identify this information, ultimately loading it to a database table and then reviewing those results in a Power BI solution. So as I mentioned, in this solution, we have a database project which contains the SQL information that I'm using. For example, I want to show how I'm going to load the risk rating scale. So I've got scripts that are loading that. I want to also show what those risk rating tables may be looking like, or those types of things. I can show you what the table is, very straightforward and not very complex. And this is for the data risk rating scale. And I also have other SQL scripts in here that will actually provide me creating a table in my audit schema and calling Exposure Data Discovery. These are just these basic and fundamental things I'm using to outline this for my database project. Primarily, we capture the data using SSIS. Now, depending on your needs, you potentially could omit this truncate because you may want to do this, collect the data over time to see if your risk rating is actually improving. I typically just truncate to clean it out to make sure that I'm getting a clean install, but you could potentially omit this and essentially collect data over time to evaluate it from a time-based perspective. Getting the Exposure Data Discovery databases, all I'm doing here is essentially, and all the queries currently, most of them are either inline SQL or driven by variables for dynamic purposes. But as you can see here, all I'm doing is I'm just grabbing the databases from SIS databases where it's not in the master temp DB model or MSDB. I really don't have any interest in those databases in this case. I'm really interested in my user databases that have been created over time. What we do then is we actually use a for loop container that will actually load the database objects in order to just show you how this is configured. So I've got this for loop container. I'm just going to loop through the objects in a given database to search all the PII related databases. I map this to an object variable. This object variable contains that, so it allows the iteration through each one, enumerating those values. And as it enumerates, it's going to be loading that information into my exposure database right here on the data flow task. And in this data flow task, again, I'm using a series of variables here. You can see that I'm using a variable here. And the reason I'm using a variable here is because this actually dynamically changes. A little bit later in the demo here, we'll show how this is dynamically changing using one of the Pragmatic Works tool called Monitoring Dashboard, which will actually monitor the execution of the SSIS package. And if you can see here, if I do a preview, it just gives me that information. And as it enumerates through this, it's loading it to my Exposure Data Discovery table here as my destination. Next, we set some simple update statements here. I'm just setting my fully qualified object name. This one right here, and this may be varies by environment. Some things, and we'll talk a little bit more about this in the presentation, but sometimes when you're enumerating or going through a dev environment, you may discover where a view, some binding errors may occur because that view has changed or the tables may have changed and that table is no longer relevant. However, it was detected that there was PII type information, so we may not want to keep that information, or we may choose to do something else. What I did do in cases where I encounter a SQL object, whether either it's a binding error or some form of error, I do keep that information separately in an Excel spreadsheet, and I'm also consuming the Excel spreadsheet in my Power BI so that I can actually go and evaluate those situations and you know, on a one-on-one or one-off basis. Next, I'm looking to now get the data discovery exposure objects. Again, this is going to now allow me to acquire data based on min and max values for the PII related columns. So for example, if I detect social security number, I want to see if based on a min and max value, what kinds of values are being returned. Are they legitimately social security numbers, or has there been some effort to maybe dummy the data, using air quotes, dummy the data up, or do they look like legitimate social security numbers? You know, this can be done, again, across environments like dev, QA, prod. And if those things are showing up, it allows you to then determine what maybe your next steps would be. But this is simply to look at this is I'm now selecting from my exposure data discovery table where my record date is I'm now using this, going to use this to enumerate, again, through an object. Here, I'm using this object array here to now fully iterate through this, setting myself up for my for loop container to obtain my min and max values. And this is where we're essentially updating those min and max values. Again, it's a for loop container. I'm doing a collection here, enumerating through that. And as we collect that information, our data flow task allows us to now, I'm getting simple values. So again, I'm using variables because the dynamic nature of this SQL statement. So it's just going to show you here what that is. But as that enumerates, this actual SQL statement changes, particularly the information like account ID. So the column value changes and where it's coming from. And ultimately, I end up with a OLDB source command, just updating those values. Now, you may say that might take a long time. Yes, on larger data sets, this potentially does. In this case, I've got roughly about 200 records. It doesn't take a long time for that to happen, but on a larger environment, this could take a while. There are other, the reason I went with the OLDB command, I wanted to demonstrate just native SSIS components that are there. There are other tools like Task Factory that I could potentially use to use a Task Factory component to do this, but I just chose in this case to use native components. Once we get through that, we're updating this information and kind of show you what this information kind of looks like here. So as I do a query here, ultimately as I come through and I've done all this updating, this information is collected in this table. You can see I've got the database, I've got the schema, I've got the object, so on and so forth. And as I'm iterating through this, here's where that sample data values, the min and max, is updating. And based on what I'm getting here, will determine what potential risk rating value I assign to it. Coming back here, the last step of my SSIS package does an update to risk rating. Again, this logic is inline, meaning I'm doing inline SQL. You could potentially, and it might be a good use of a stored procedure. That way, if you were using a stored procedure, you just update the logic within your stored procedure. But for these purposes, here's what my logic currently looks like. As I do this exposure data audit, one of the things it allows me to do is to look at what values are coming back, what the information is. Do I need to potentially adjust this risk rating information or adjust this logic to possibly either decrease the risk rating value or increase based on what I'm seeing in the data? So what we have there is that's essentially our SSIS solution in a nutshell, kind of a code review type format here. Next, what we're going to be looking at is now the Power BI solution. Now this is again kind of reiterating some of the pieces of information I've already talked about, but what I did here is I pointed my Power BI solution at my exposure data audit table, and then I wanted to evaluate and visualize and analyze the data that was coming back. So just to kind of hear this introduction page or this overview page. Again, the primary objective is to review the exposure data audit data and to determine what elements are relation to the PII. And again, I'm evaluating a SQL 2016 instance. Some of the things that are being looked at here are things like social security numbers, tax ID, and etc. Things that could potentially be tied back to an individual that could uniquely identify them in some way. And as we mentioned, it was a three-part solution. So I had an SSIS package, which loads the data. It's using a risk rating scale, which is what we see here on the right-hand side. I use this risk rating scale to evaluate what the data is and what the rating and what the possible risks are. And as we walk through this, the Power BI solution here on the lower right-hand corner is the explanation of what each tab represents. So after I've done my exposure data audit and I did a refresh on my Power BI, here's the summary level of this information. So I'm going to come back and show you here. Really, one of the things I did in this was to assume that if we were at a risk rating of 2 or less, we were probably in good shape. If we get to anything 2 or higher, we probably want to start kind of evaluating what types of steps we may need to take, either through just evaluating data and adjusting the risk logic, or do we need to start considering things from a database security perspective in order to obfuscate the data in a proper way. So with this, I have got a risk rating value, and it shows you some of this information, and I actually sorted on the risk rating. So in this case, I sorted to the highest, what's bringing back the highest risk rating. In this case, 4 is our highest risk rating possible, and our worldwide importers data warehouse apparently has 12 columns that are meeting this criteria. If I wanted to see what those columns are within worldwide importers DW, I've got an audit detail tab here, and I can actually come down here and look at this worldwide import and look at what is coming back as high. As we see here, my total including tax, these values here don't necessarily mean like tax ID, social security ID, but the way my logic was originally set here was looking for the word tax, and anything that had tax in it, we were potentially going to assign it a risk rating of 4. Now, looking at these, you wouldn't say, okay, these look like just total value, so I'm not going to really need maybe assign these to that high level, highest level. So one of the things I was going to kind of show here is if I come into my SSIS solution, and I want to update this risk rating values, for example. And because of those values, they're appearing like they're probably going to be nothing that's going to identify my solution or individually identify someone. So I'm going to probably tuck it right in here. It's going to be a risk rating value of 1, which is our lowest risk rating value. And I've got this kind of already prepared. I'm going to copy this guy in here. And just change that like so. I'm going to say okay, okay. Now I don't necessarily have to run or rerun everything in this. I'm just going to execute this task real quickly to show that update. And it's quickly done. Now if I come back to my Power BI and just do a refresh, we'll notice that all the highs, at least most of them, will go away. There we go. So I also could include this in my logic. So now, if I come back out here, we can actually see that my worldwide importers database is actually now significantly reduced its risk rating level. And this kind of demonstrates this. Obviously, with this risk rating scale, I can show you what, based on reputation impact, personal safety impact, property damage impact, if that's relevant, or resource impact. This is around personal resources within your organization. Again, it also reduced our overall risk rating a little bit. We're still a little bit over over 2, but high level. For example, we can just bring this down. Worldwide importers. It shows us that we still have a few. We do still have the 12, but now we only have 3 columns in that high risk rating, and we only have 1 in that no risk level. On the invalid object side of this, as I mentioned, I've been tracking some of this, and I'll get to this in a minute. One of the things I ran into in this one, it appears that there was some memory optimized data within one of these databases, and when you're doing queries, one of the things a memory optimized table does not do, or indexes does not do, and does not allow you to do cross database queries. So I was unable to get that situation resolved, but let me get to this information here. So this is some of the things I ran into. I believe I got it right before the presentation here. I was actually able to figure out what was going on. I didn't have time to make adjustments to the SSIS package, but essentially what I'm going to have to do is be able to detect what tables or indexes or those types of things might fall into a memory optimized data. I haven't figured out how to dynamically determine that, so that would be one way that I would augment or adjust the solution to handle these types of scenarios. And as I also mentioned a little bit before, binding errors, that's something like if you have a view that's referencing a column that's no longer available or a table, and it happens to just be setting out there. As I mentioned, I had run this in a dev environment for, and I detected binding errors. I did keep track of those offline to show that maybe we need to either eliminate the table altogether, the view altogether, or to adjust to figure out what kind of steps we needed to take from a exposure data audit perspective. So with the release of SQL Server 2016, it introduces some new features, improved performance, and continued effort on enterprise-grade security. We're going to kind of look through some reference architecture, and is really designed to provide data protection using transparent data encryption, always encrypted, row-level security, and dynamic data masking. So one of the things I also wanted to really quickly jump back to is my SSIS package. I wanted to kind of show you this, and hopefully that we will show an example of this. I'm going to go ahead and execute this package. And as it executes, one of the things I wanted to show here is as it executes here, you're going to start seeing, and this is what we're looking at here, is a pragmatic workbench monitoring console. So this is actually going to tell me how this thing is working. So one of the things I wanted to show here is actually once it's going through these, you can actually see these variables. One of the reasons I also use these variables is because within the monitoring console, I can actually see these in real time moving through each cycle. And it's also telling me how many records I'm loading. So for example, if I come down here, I can show you this sample value here. You can actually see this changing in real time as it's updating. This is seeing here. You can see it now. It's moving through PW Insurance DW, a DIM company. As it continues to load through that, now DIM customer. So I'm automatically loading through this. You may see some that are green and red and so on and so forth. These were things that were troubleshooting. As I mentioned, one of the ones that I kept running into is this guy right here, this error here. And what, again, this appears to be, in this case, something related around memory optimized tables or indexes. And I've got to work through that to figure out exactly how to dynamically detect these. So this is, again, how I was able to detect some of these errors in this. And if you're not familiar with Pragmatic Works toolset, it's a great toolset, particularly monitoring console, to help you understand kind of real-time analysis or when something actually potentially fails. So I'm going to jump back to my package it's currently running, and you'll see that it's continuing to update. I've updated roughly 106 records here. It shows you in real time how many of it succeeded. Eventually, if there was something that failed here, it would show me where it failed. And we're getting through this, and once it gets through to roughly about 200 records or so, you'll see that it will proceed on to the SQL execute task there for updating the risk rating values. So this is just another way to troubleshoot or evaluate in real time how this SSIS package is actually performing. So back to this screen here. With the introduction of, again, SQL Server, we're going to be able to protect data at rest and in motion, provide data to only those who should see it, protect our data at the role level based on user access, or dynamically mask data. Now, these are just quick overviews of what some of this technology does at a database level. So transparent data encryption, or you also will hear it referred to as TDE, has been in SQL Server since the 2008 release. It is really kind of the primary cornerstone of the data security at rest. Transparent data encryption secures databases by encrypting the data on the media it's stored on. So furthermore, the data is secured via a data encryption key, which prevents unauthorized access to the data. The server performs real-time encryption and decryption of the data in data files and log files. This meets specific regulatory and compliance rules in your organization or in the marketplace. Again, TDE encrypts data at rest, but not data in flight. Other encryption methods are required to encrypt data in communication channels or across the wire, across the network. Just from an encryption architecture perspective, TDE uses symmetric keys and encryption to manage the data in a SQL Server database using transparent data encryption, TDE. The encryption applies to the entire user database. Next one we'll talk a little bit about is always encrypted. This one was new in SQL Server 2016. It provides allowing us to protect data in flight and at rest. This allows for protection of sensitive data such as credit card numbers, personal identifiable numbers, personal identification numbers, as well as sensitive company financial information. This is the first time in SQL Server we have been able to truly separate who can and who can't see sensitive data. Always encrypted is transparent to the applications using a driver installed on the client's computer. Some key things to understand about always encrypted is there's this notion of deterministic versus randomized encryption. Deterministic encryption uses a method which always generates the same encrypted value for any given plain text value. Using deterministic encryption allows grouping, filtering by equality, and joining tables based on encrypted values, but can also allow unauthorized users to guess information about encrypted values by examining patterns in the encrypted column. This weakness is increased when there is a small set of possible encrypted values, such as true, false, north, south, east, west. Deterministic encryption must use a column collation with a binary true sort order for character columns. Then on the other side of this is the randomized encryption, which uses a method to encrypt data in a less predictable manner. Randomized encryption is more secure but prevents equality searches, grouping, indexing, and joining unencrypted columns. So these are some of the things that you want to look at, because there may be different needs that you have across the organization. Also, with always encrypted, you have column encryption keys used to encrypt the sensitive data. Stored in the database columns, all values in a column can be encrypted using a single column encryption key. Encrypted values of column encryption keys are stored in the database in system catalog views. You should always consider storing column encryption keys in a secure, trusted location for backup. Some of the use cases we can talk about here a little bit at a high level. For example, a customer has a client application and SQL Server both running on-premise at their business location. The customer wants to hire an external vendor to administer SQL Server. To protect the sensitive data stored in SQL Server, the customer uses always encrypted to ensure the separation of duties between database administrators and application administrators. The customer stores plain text values of always encrypted keys and trusted key store, which the client application can access. As SQL Server administrators have no access to the keys and therefore are unable to decrypt sensitive data stored in SQL Server. Another one possibly is client on-premise data in Azure. Customer has an on-premises client application at their business location. The application operates on sensitive data stored in a database hosted in Azure, say for example, SQL database or SQL Server running in a virtual machine on Azure. The customer uses always encrypted and stores always encrypted keys in a trusted key store hosted on premise to ensure Microsoft Cloud administrators do not have access to the sensitive data. Another use case would be, say, client and data in Azure. A client or a customer application hosted in Microsoft Azure, say for a worker role or web role, operates on sensitive data also stored in Azure. The customer uses always encrypted here to reduce security attacks, surface areas, and the data is always encrypted in the database and on the machine hosting the database. So row level security enables customer to control access to rows in a database table based on the characteristics of users executing a query. So based on execution context or security levels, or maybe possibly AD group membership. Row level security simplifies the design and coding of security in your application. Row level security enables you to implement restrictions on data row access. So for example, you want to ensure that workers can access only those data rows that are pertinent to their department, or restricting customers' data access only the data relevant to their company. So like in a multi-tenant scenario. The access restriction logic is located in the database tier rather than away from the data itself in another application tier. The database system applies access restrictions every time the data access is intended for any tier or from any tier. This makes your security system a little bit more reliable and robust by reducing the surface area of your security system. Some use cases here: a hospital can create security policy that allows nurses to view data rows for their own patients. A bank can create a policy to restrict access to rows of financial data based on the employee's business division or based on the employee's role within the company. Multi-tenant application can create a policy to enforce a logical separation of each tenant's data rows from every other tenant's or organization role. There's some use cases around row level security. Dynamic data masking limits sensitive data by masking it to non-privileged user. Dynamic data masking helps prevent unauthorized access to sensitive data by enabling customers to designate how much of that sensitive data they want to reveal with minimal impact on the application layer. This is one of those features that allow you to roll out dynamic data masking to limit to the exposure of sensitive data. Really, the purpose of this is to really look at some of the use cases. Really, one of the most common one would be using dynamic data masking to mask PII data, for example, social security numbers, credit card numbers, etc. So that pretty much concludes the presentation and demo. Erica, we can open it up for questions now if we have any.
Yeah, sure. Let me go ahead and open up the question or the chat here. All right, so if you have any questions, go ahead and feel free to type them into the chat panel, and I'll go ahead and ask Alan. So I have some questions here. How did you enter comments in the SSIS package?
Enter comments, great question. Let me just jump out there and show you that real quick. I'm assuming we're talking about the annotations here, right here, I'm assuming. So if you add a annotation, so if you right click in any of the, in the panel here, your design interface, if I right click on that, you're gonna get this context menu. If you say add annotation, I can start typing comments like so. Great question. For example, that is, and I'm assuming that was what the question was.
Yeah. Sorry, looking for our next question here. I'm having a lot of people enter their questions. All right. How does toe-level security work with a select query comprising multiple joins?
Row-level security comprising multiple joins. So if we get into row-level security a little bit, so if we want to essentially go row-level security from a database perspective, we can get into the query side of it, some of the best practices around that. So queries around row-level security, again, looking at that, let me see if I've got an example here. Trying to find my examples. So you're basically, if you're going to now grant select, you would grant the select to a given row or access to in the case that we were using the patient table. So I want to grant, say I've got a row for doctors, nurse, and volunteer. You create, essentially you want to create an inline table function which allows those rows to be identified. And then once you create those rows, you can actually say select for execute as user, for example, and I'm going to just copy this out here and show this in a, I don't have this configured, but you could potentially do this. Yeah, we'll see if it's going to cooperate with me. Okay. So I thought that was going to work. I may have to answer that one offline because I'm not sure if this is going to work. There we go.
Yeah, so, no problem. I'll be sending you all these questions after.
And then once we get that role set up, then we can potentially do the joins on that. Now, again, the joins are going to be based, if you're doing joins, and this I don't have an example here, and I'll be glad to answer this in a little bit more detail, but you still can, it would be based on what access. So for the example, this table patient, if you're joining it on another table, it's going to only filter based on what's being returned from that patient table. So you're only going to get those types of things. I don't have an example of a join here. Obviously, I don't have a database I can show that with. I would say this would be an extension of this presentation and demo of actually incorporating some of these data security options to show that. But I'll take that one offline. I think that's more of a detailed answer than I've got available for us right now.
All right, next question here. Tony asks, what was the risk rating custom to your application, or did you start with something generic? If so, where did it come from?
Right, that's a great question. I will get you a link to that. It was, I just was looking for a risk rating scale that seemed reasonable. I searched online and said risk rating scale, and I found that risk rating scale. Now, there may be more pertinent ones to your organization, but I ended up using a very generic one. And in here, let me come back out here. In that one, I just looked for my from this, I just incorporated that risk rating scale. So let me just show you what that looks like. Just a simple table. Here's the table translated from this here. So I translated this risk rating scale to this table, and that's how I leveraged it. And I just found these. It was just kind of a static one. I leveraged it. I'll be glad to provide the links to that. in response to that. Also look for a blog update on this kind of information. But yes, I can send that information out. But it was just something I obtained offline or online, essentially.
All right, and I have a couple of people asking if the SSIS solution materials will be available. Are you comfortable with sending that to me?
Yeah, we can work on that.
Okay, perfect. All right, so if you are interested in those solution materials, just reach out to me, Erica, and that would be at etotten@pragmaticworks.com. All right, next question here. How are always encrypted keys different from symmetric keys in terms of column encryption keys?
So column master keys, and we're talking about that. Column master keys are keys that are used to encrypt column encryption keys. So the column master keys must be stored in a trusted key store. Information about column master keys, including their location, is stored in the database and the catalog views. Column encryption keys are used to encrypt sensitive data stored in the database columns. All values in the column can be encrypted using a single column encryption key. Encrypted values of column encryption keys are stored in the database in system catalog views. So those are the types of things we discussed a little bit earlier. I'm not sure if that was the right. Can you ask that question again, or at least make sure that I get that question in the updates, because I want to make sure I get that answered. Because again, this presentation is primarily on detecting it, not necessarily applying all these security type options we'd have. The next presentation, extension of this would be to go through that. But I will make sure to get that reply specifically out there. But let's see. Again, if we go back to the presentation here as well, let me come back to this. Always encrypted, and show current slide. Oop, I'll do this slide. All right. Well, I'll answer that one on the follow-up, Erica.
Sounds good.
Anything pertaining to the security stuff, I'd be glad to do that offline, actually.
Great. We have another question here. Sarisha asks, we had a request to match the randomized encryption implemented by the client. Is this possible?
So ask that again.
We had a request to match the randomized encryption implemented by the client. Is it possible?
Match the randomized encryption.
Correct.
I would probably need to see an example of that. Again, all the security related feature questions I would like to kind of take offline.
Okay. For masking sensitive data, do we need to do this while creating the table or column? I'm interested in masking the data on the fly via SQL and also want to keep track of what is the original value and the masked value for traceability purposes. Right.
Again, I would like to take all the security related questions like that because it's better to just do those offline.
Okay. All right. Searching through, I know a lot of these are security related.
Yep.
And
there may be a series of blog posts around that because it really depends on your situation as well. You know, trying to understand
right.
high level questions like that. the security stuff is not necessarily high level. It was again we hit overview elements, the things trying to understand very quickly in your situation what may be the case. I would instead of giving you kind of a really high level short answer, I'd rather really understand the question and try to provide some guidance in a more detailed level.
Right. Okay, here's another question. Is the PII information identified based on the column names? Can we identify from the data itself?
I would say that is possible. One of the things that I had contemplated that is looking at that option. Right now the solution is based on PII column names, but the next extension of this solution would obviously be saying using some type of technique to identify whether a pattern in the data, for example, would allude to either like a social security number or credit card number, those types of things. But this solution specifically was around PII column naming standards.
Okay, here's another question from Jeremy. Would date of birth be considered PII if you have no related name, social security number, or other identifiable information?
Not necessarily. Again, it's really what makes in your organization PII. Date of birth in and of itself probably could not identify somebody uniquely, but let's say date of birth in a combination of somebody's first and last name, for example, could potentially uniquely identify somebody. But date of birth in and of itself, I doubt would uniquely identify somebody.
All right, here's another question. My company wants to use ideal SQL compliance. What is the difference between yours and ideals?
I'm not familiar with ideals. Well, I'm not familiar with that.
All right.
You can send me some information on that to understand what that is. I'm not familiar with that.
Mm-hmm. Is encryption for Azure available in SQL Data Warehouse?
It is. Again, it's one of those security, but I know that transparent data encryption is available in Azure.
Okay. Is there a central agency that governs the definition of what PII is, or does the definition vary by industry?
And that is a fantastic question. As I alluded to in the earlier slides, the definition I used came from the U.S. Department of Commerce, and essentially the way the U.S. Department of Commerce defines PII is as any information about an individual that can be used to distinguish or trace an individual's identity, such as name, social security number, date, place of birth, mother's maiden name, or some biometric records. I don't know that there's any governing agency, or but it could vary by industry. So it may vary on by if you're a financial industry versus a medical industry. We have HIPAA compliance laws. We have on the financial side SOX compliance. So those are two different compliance regulatory type things that in some ways are similar, but there may be differences between them because of the industries that they represent, for example.
All right, and I have a couple people asking you to put your contact slide back up just so they can jot down your contact information for some questions.
Sure.
All right, and as you're doing that, here's another question. Arnold asks, is your PII criteria based essentially on min and max of each column?
No, again, this particular solution is only based on column naming standards. In the data, the reason I grabbed those sample values is I really wanted to see what kind of data was related to that given column. So I used a min-max function, say give me the min account ID, max account ID from this table to see what that type of information was. but it was nothing from a logic perspective where assigning the risk value was based on the values coming back. I was really using the values for reference purposes in this case.
Okay. Here's a question from Keith. When scanning for PII, are you just exploring? Oh wait, that's the one. Sorry, I've got like so many questions in here. Margaret asks, what's the overhead on running the process? Let's say in an environment of 500 databases. Can it be run during a regular business day?
500 databases, and is that in one instance of SQL Server, or is it distributed across multiple instances?
She doesn't specify here.
Well, it would take a while with that many databases.
You said distributed.
Okay, so that obviously I don't. It really depends on how active that server is and what its workload is. In spite of doing this, again, all I'm doing is issuing very simple, straightforward queries. I would say the overhead would be minimal, but you would want to evaluate that on a case-by-case basis, especially with that number of databases, because you're going to collect probably potentially thousands to tens of thousands of columns potentially. And this is one of the reasons when I mentioned, let me jump out here back to that solution. This right here, there are some task factory components that possibly would be a little bit less invasive and over the top. For example, this right here is kind of a row by row update. So I'm basically using an OLDB command to do the update. So you could potentially have, this could possibly be kind of invasive, if you will, because again, it's going row by row to update my exposure data discovery table. In my case, it was minimal, but I'm not evaluating 500 databases. I'm probably evaluating about 20 to 25 databases in this situation, in this solution here. I would say if you're getting into the hundreds of databases, it potentially might be something you want to do kind of overnight, over the weekend kind of a thing, would be a suggestion. Or if you wanted to limit it to a certain number of databases, you could do that. But if you were going to do that during regular business processing, I would definitely monitor to see if you're having impacts to performance of the workload of a given SQL Server.
All right, I'm gonna give you one more question here before we wrap up, because I know we're getting close to noon. Could this solution be built within a stored procedure? I was thinking if the user executing the audit needed to run on demand and did not have the higher access to invoke an SSIS package, or if the BI was built a direct query, the SSIS would not be real time to the environment.
I would say it's going to be difficult. Not that you couldn't do that, but I'm a big fan of doing using tools that are good at a certain task. And where a stored procedure potentially breaks down here is, you could use maybe like a table variable or something like that, but iterating through all that in a stored procedure would be probably not the best use of a stored proc. I'm not saying that you couldn't, but I would recommend using SSIS as a possibility. If you're wanting somebody to invoke a stored procedure, I would argue that you're probably going to have better luck doing it this way than through a stored procedure.
All right, perfect. You ended right at 12, so I'm going to wrap this up. Thank you so much, Alan, for taking the time to present today, our first free webinar of 2018. And thank you, everyone, for joining us. As always, we do record all of our sessions, and we will be sending all of you a follow-up email that includes a link to the recording of the session. You can also find the recording on our website at pragmaticworks.com. I usually get it up on the site a few hours after the end of this presentation. And also, if you would like to email me for the solution from this presentation, you can go ahead and do so at etotten@pragmaticworks.com. So thank you again for your time, and we look forward to seeing you all next Tuesday for another free training session. Thanks again, Alan.
Thank you.